Hello friends, myself Pratik. Welcome to this session on growth and decay of data. In this section, we will understand the need of looping statements and its usage. We will be learning this concept through various case studies. Let us start this session. Let us consider this example. In this, we have to write a function growth that simulates a population growing by 3 individuals each day. It means we have to develop a function growth. If you observe closely about this problem statement, we have to assume our initial population. So let's suppose our initial population is 1000. It means after one day our population will become 1003. It means 3 more people are added into our current population, that is 1000. So 3 people are added into it and it becomes 1003. So after one day we will be having 1003. Same way, after 2 days our population will be 1006. It means that 3 more are added into our current population, and after 2 days we have 1006. After 3 days 3 more are added into 1006 and we finally have count 1009. So same way, after 4 days our population will be 1012. Here we are depicting that our population is growing by 3 individuals each day. Now the question is, can we generalize this? So if you observe closely, you can see that I'm just accumulating 3 into my existing population, and I'm keep on repeating this statement for each day. So let's suppose if I have to find out my population after 2 days, means I have to repeat this 2 times. If I have to find out population for 4 days, means I have to repeat this 4 times. So there is one initial population and we have to keep on repeating this statement, which is equal to the number of days for which I wish to have my total population. So we can generalize this and we can create a for loop, because whenever you have a statement or group of statement which is repeated multiple times, we can replace that in a loop. So we can create a for loop which can control the value of number of days. So let's suppose if we wish to have our population for 5 days, so our for loop will run from 1 to 5. So can you write a for loop for this? Let us first discuss the syntax of for loop. So the syntax of for loop is for variable in range, and here in brackets we can pass 3 parameters, that is start, stop and step. Then we have a colon, and under this block we have to give our statements which we wish to repeat. So here it's important to note that our counter will start from this value, and start value is optional. If this start value is omitted, then our counter will start from 0, but otherwise we can specify any start value. Second parameter is stop, which is a required parameter, and this is the end value of the range. And it's important to note that this value is exclusive. It means that loop will iterate up to this point but not including this value. So this stop value is not included. Let's suppose if stop value is 5, so it can go up to 4, that 5 will be excluded in that. Then we have a step value which is optional, and step is actually the value which we wish to increment or decrement, and if it is omitted then its default value is 1. So the only thing which is mandatory out of these 3 parameters is stop value. Start is optional, by default it starts from 0, but we can specify any value. Step is optional, by default step value is 1, but we can specify any positive or negative value for increment and decrement in desired steps. Stop is mandatory, and it's important to note that this value is exclusive. It means the specified value is not included. So for example, if stop value is 5, the counter will stop at 4. Let us consider one example. So for example, if you run your for loop like for I in range 1 to 6, here this is considered as start value. So it will start from 1 and it will go up to 1, 2, 3, 4, 5, and 6 will be excluded. And in this for loop, we are just having one statement, that is print I. We are printing the value of I 5 times. Based on this discussion, can you write a code for this growth function? So I will be discussing the solution of this in our next session. So please take your time to write the solution for this growth function, and then you can compare your code with the solution discussed in the next session. So see you there in the next session. Thanks for watching this video.